Now, again, a couple buildings later, we did this building in Munich, and this is a commercial building. This is a rental building, and we worked very hard, and because we knew that we couldn't do the double wall, we couldn't have the sophisticated controls. From a plan point of view, it had to be a more conventional building. And again, you see here it's a stainless steel grid, and it has a system which it's two parallelograms with a cut-off roof. There's a static lighting system which reinforces the corner, and a dynamic system which reinforces and highlights the elevator cores which partially stick out of the building, and the bridges which connect the building on certain level. So it's this element of the static office cubes, which are blue lights, and the other lights which change about every 45 seconds, slightly from the top to the bottom. This building has totally different appearances at different lighting conditions. This one is a morning light, and this is from the northwest, late evening light. There's two low buildings, as you see. This in front is a hotel, 200-room small business hotel, and another low office building. The building had to follow a certain master plan. The building is 130 meter tall. The Deutsche Post Tower was 140, and the Sony building was 100. And this is in between the buildings at night, and there's actually a lot less lights than you see in that picture, which is obviously the effects of the reflectivity of the glass. And you look towards the hotel, and this is where the lighting changes in the tower, and this is where the bridges are kind of lit up. And this is the elevator core in the building, looking from one to the next building. They are all glass cores, and this is the plan. It's actually what we call in Germany a Zweispanne. It's a center corridor building. The core is on one side, obviously on the inside, and it gives actually a lot of flexibility for bigger office spaces at the ends, and allows for on the right side for deeper offices with a narrow corridor, or from some smaller offices with an open work area in between. And in order to make this building's structure stand up, because as commercial buildings, when we designed them, they didn't want to commit that they built the two buildings together. They couldn't be tied together like the Post Tower, and so they are individually independent. And that building is a little less than 14 meter wide and 130 meter tall. So it's a ratio of 1 to 10, which is actually much more slender than the Hancock or the Sears Tower. And so there is vertical trusses, which there's two of them in each building, which actually out of steel, and the slabs are out of concrete, a composite construction. So the conditioning system, the climate system, is such that you again have the slab with the integrated piping. You have the raised floor, and you have the individual units on the outside. In this case, the client didn't want the air to take from the outside facade, so the air comes from one fan room on the floor. So there's a certain amount of ductwork which brings that air in to this perimeter units. And then if additional cooling is required, every second space is empty, there can be an induction unit which takes air from the room and cools it down. Because the tolerance level actually for the typical German building is about 26 degrees Celsius. And everybody is worried over there when an international client, a bank like Citicorp or a company like IBM or comes, they want 22 degrees. And that can be accommodated by putting this additional units in. So the facade is a system of horizontal bands of stainless steel, and you see these vertical bands, which are actually a perforated metal, a metal screen, and behind that metal screen are operable every second one. Again, you see every second unit bring the fresh air inside the space, and obviously that metal screen gives a protection against falling out, gives a certain wind protection, and gives a certain rain protection for a drizzle or something. So what this building also has is triple glazing, which makes it then perform on a level kind of very close to the Deutsche Post. So this is this facade. You see actually how transparent the glass is, and what you see inside the slabs, and you see actually how simple a building can be. Here you see this diagonal bracings on the building. This is a close-up of this metal screens, and this is from the inside. You see there are open windows, and you see how this is on the top floor. And this is a typical office space. There are suspended light fixtures, which we also designed, very minimal, which have a downlight component and an uplight component. In a building like this, we only have, if I go just quickly back here, we only have 22 centimeter, in this case I think it was 25 centimeter raised floor and 22 centimeter. We have less than 50 centimeter, foot and a half for the ceiling sandwich. It is at an 11-foot high. We got about 10 foot clear in the building. So, which is another point when we talk about sustainable buildings, buildings which are done with minimal effort. I mean, as you see, I'm trying to not say green buildings, and the effort. How to build buildings in such a simple way? I mean, that, and I can't put a number to this, whatever. But my sense and my intuitive feeling tells me that this goes a long, long way. How a building ultimately performs, and because as we all know that so if a building is very complicated, what effort it takes kind of to build it is something which is sometimes not very, very responsible. And there's a lot of this going on in architecture today, where I think just